Okay, we got the grease in the bottom, we got the gear all cleaned out, both gears, and it reinstalled, and now I'm going to pack it with grease and put the armature back in. And we're going to fill it all the way up and cap it. So everything's clean and nice and neat. Okay, I got the armature back in, and I just wanted you to see how those gears are supposed to pull up the grease. See how they pull it up there at the back gear? It just sucks the grease up. I don't even have this full yet. Look at the wormwood down there. So we're going to go ahead and turn it on. And you see I got it on 50 volts and it's already turning very little. So I'm going to crank the voltage up. And you see how that just pulls that grease right into the drive. When you have old dried up grease in there, it won't do that. So see how the grease folds in on itself on all of the gears? I can't go full speed because it'll splatter grease everywhere, but it gives you an idea why those gears have to be clean and all the crud has to be out of them. So now I'm going to go ahead and reassemble the gearbox, and we'll see how quiet it is. Okay, Paul here, and I'm continuing to work on this GE fan. I'm about to change the head wire here. You see how corroded it is. It's a wonder it didn't short out on the armature there. The wires are actually bare and showing. And somebody did a ridiculous repair here with electrical tape. You see where it's going through the body. It's about busted off there too. Getting this out of the housing, the stator out of this housing, was difficult. Of course, I'm going to clean this up before I put it back in there. You see the grease and stuff in there, dried up. Look, it's dried like a rock. And that was probably not very good for the coil for sure. The way this comes out is it sits in here on this pivot. It sits inside this base here and pivots in there, and it has a screw on the top that goes down into here and holds it in place so it can just turn like that, but not this way. So we can clean this out good now that we got it off. I might as well go ahead and clean it some more. I'm also going to clean off the stator itself. You see it's got dirt and grime on it. I already wiped it once, but I'm going to wipe it down some more. You see there's some dried grease there. See? So I'll get that off there and clean it off. Get it looking like new. There is some bends to the plates here, but it's just the outside plate, so that shouldn't be a problem. That solder weld joint came undone when this was, I don't know, maybe somebody had tried to get this out before and they didn't do the right thing. The way to get these out of the case, out of the housing, is, especially if they have screw holes in the back like this one did, you don't want to use the existing screws. Somebody had banged on them once because they're brass and they will bend, they will smash. You get a stainless bolt, but you got to make sure it's the same size diameter and that it is machine thread, because you don't want to put anything in there that's not machine thread. And you put these down and screw them in about 10 turns so they're well into the threads of the stator, and you just lightly tap with a rubber mallet one side, take the screw out, put it in another side, do it again. If you got multiple screws, you can put screws in all of them. I would suggest getting longer screws. This was the only one I had that fit this particular unit. And once the stator gets close to the bottom here, you know, do it on something solid, then you're going to need to use a vise, and you put the vise so that you close it so that it just barely goes under the edge here and on the opposite side where there's two screw holes. right on the edge. You don't want to go in because you'll mess up the threads of the stator banging down, and the stator can't move if it's hitting the vise. But if the vise is just barely on the edge there, so it's up like this, and the vise is closed, then you can go from one side to the other and slowly, just slowly. I mean, you're talking a 1/16 to 1/8 of an inch movement on this as it creeps its way down. To help with getting it out, you can also, before you get it to the actual rim, while it's still recessed just a little, or even when you stop for that matter, you can put some 3-in-1 oil around the edge of it and let it sit like this for a while, let the oil sink between the housing and the stator as much as possible. Then when you flip it over and start tapping, that oil will also help assist it come out. Okay, once you got it out of the housing, then the next step, and the reason you have to take it out of the housing is because the wire goes this way through the stator and connects in the back here. These are your head wires. If you cut it here and splice it, you're going to have a problem. This wire has to be replaced right through the stator head. So I'm not worried about this wire. I don't care if it breaks or whatever. What I'm going to do is disconnect it, run the new wire through, connect the new wire through, cut a piece long enough that I need and run it through there and connect it to the switch. Then I'm going to be replacing the cord with the same wire. This is a 2-head wire stator. It has just 2 wires going to the motor. Some have 3, some have 4, some have 5. Depends on the motor, but this one only has 2. So we're going to disconnect the stator here. I'm going to take this old rubber gunk off the stator. Be very careful of these wires. They connect to little copper wires that go to the coil. You don't want to break them at all. So be very slow in removing the insulation, and I would remove just enough insulation so you can cut the existing cord and pull it out, run the new cord through, and then use heat shrink to shrink the cord back on, which you'll see how I've done it after I've done it. I don't have enough memory left on my camera here to actually leave it running, so I'm going to shut it off, but I'll show you step by step what I'm doing as I go. Okay, here's the wire that I'm going to use. Made in USA. It's amazing that you can still buy wire made in USA, or anything for that matter, but it's good wire. And this is it here. So what we're going to do is take a piece of this. You see it's plenty long enough. I think it's 8 feet, so I'd have enough for the head here. And the trick is getting this old wire, this new wire, through where the old wire is. This is thicker wire. So what we're going to do, you notice I took the tape off what they had taped. Look at that. Why would you tape that? It didn't even have any insulation. It's just bare wire. You know the other one's just as bad. So what we're going to do is cut the wire here, tape the end of this wire to it, and gently, then I'm going to cut them off right here. I pull them out. You see I gently pull them out enough to get to the wire. I'm going to cut these so that I'm not putting no pressure on this. Tape the new wire here. Take some pliers or tweezers or whatever and pull the old wires through while feeding the new wire in. And that's the easiest way to get that wire to go through there. So that's what we're going to do. I'm also going to clean my fingers and get some of this grease off and put on some latex gloves, which will help me keep from spreading grease all over the place. It may or may not help, I don't know, but I'm going to try it. Should help me from keeping grease from getting on everything, including that new cloth wire. You know, something's going to get on there. I can't help that, but I'm going to do the best I can. So what we want to do is just strip a little bit of this, and I'm going to take that tape off, but I'm going to put a piece of tape. Actually, I'm not going to do that. I'm just going to take my X-Acto knife and get some of the insulation out of the way. This cloth covering will unpeel easily with your fingers. They just come off once you cut it. You don't even need to cut it as far as you want to go. But I'm cutting it a little further because I want to get to that housing. Once I get it through, I can just snip it wherever I want it. But to get it through there, I want to pull this back as much as I can. Yeah. Now I'm going to get the housing out of the way. Yeah. And I don't need, this is a 3-wire system, which I bought so that I could actually ground the motor, but it don't matter. The 3rd wire doesn't need to be used, so it's not a big deal. You want to get as much of this junk out of here as you can. Actually, I say junk, I shouldn't say that. It's very good wire. You notice they put that hard plastic covering, and then they put this fiberglass wrapped around all of the wires to protect the wires from being yanked or whatever. And of course, they're not rubber, so they're not going to corrode in any time soon. Well-made cord. As you can see, I can't hardly cut it. So now I got that about where I want it. I get a little bit more off of this stuff. Now I want to cut the insulation as smooth as I can because I don't want it to unfurl as it goes through the stator. So I want to get as much of that as I can get, but not all the way past where we're working, and take it off. Get it as smooth as you can. Just keep like twisting it if you have to. Be very careful with the knife so you don't get cut. Once you get it down so that it's smooth like that, then you can take a piece of Scotch tape, some kind of tape that's kind of thin, and the idea is just to keep that from peeling. But you want to start the tape so where it's past the plastic edge so that it acts like a buffer to get the plastic through the stator. See? That'll keep it from unraveling, and it's past the end of the plastic. Now we'll cut these, and what we'll do is just bare these if I can. Not caring if I cut into the wire too much or whatever. I just trying to keep enough of the wire there that I can use it to pull with. Yeah. Okay, so I got one there, and I'll do this hot wire the same way. I have a stripper, but it's one of those big strippers that won't fit in there. Okay, now I twist them like that, and we want to bare this a little bit, same way. And we're going to take these and run them between that one. Twist those together. It's kind of hard to do because of nylon insulation that's still there will get between the braids and try to make it untwist. So you gotta just kind of get it as best you can. Now this one here, you just cut it off because you don't want it binding as it goes through. Okay, that should pull through. And you take another little piece of tape. Now, it's not going to want to stick because there's so much oil and grease on there, but you do the best you can. It'll stick to itself, so wrap it around as tight as you can to that head wire. Okay, now we're going to cut. It'll stay, it'd be nice. Okay, I'm going to cut these head wires right here, leaving plenty of the original stuff till we dig it out and see what's in there. Okay, and we're going to pull that through and feed it through at the same time. Try to get that tape to go through there. Now the wire is going to be stiff, but you see, no, it didn't work. But it got us that far, and we were able to push it the rest of the way. We got it almost all the way through, and that was great. That's what you want. Once you get the wire through like that, then you can get some kind of pliers and feed it through the rest of the way. Maybe. There we go. There. And I got plenty there. It might take a little bit more, but now you can grab the plastic housing and just ply against the case and it'll pull more out. Get any loose wires like those that fall off and get them out of the motor. Don't leave them in there. Notice all the grease and goo coming off those old wires and stuff. Okay. There we go. That's plenty. And take your old plastic tapey stuff off. And I cut my fingernails, which was a stupid thing for me to do. Okay, you get the old tape off there. So you can get to the wires. I only need two, so the ground wire or the neutral won't be used, one or the other. And I don't really care if this unravels anymore, because it can only unravel to there. So, you know, don't worry about it. I just kind of cut it for convenience sake, get the worst of it out of the way so I can work without it twisting in the copper braids. Like that. Be careful not to cut the coil. Yeah. Okay. So we will use, I should have probably just, yeah, whatever. I should have just cut the green and not the neutral, but it doesn't matter. If I need to pull more wire through, I got plenty to pull through here. Okay. Now, get the housing off some. So that you don't have a big old bundle of wire, because you don't want nothing touching the armature, obviously. You want it to free spin. Yeah. Okay, I'm going to cut the ground. I don't need the ground wire. You don't have to worry about it shorting or anything, because if it touches the metal, all it's doing is grounding it, which is fine. And we want to go ahead and strip the wire. Okay. I'm going to go ahead and do this off camera. It's going to take me a little while. I got to really clean these up, you see, before I even worry about stripping that and doing that. I'm going to take the tape off this. And this is old bulldog tape that they used to use before they came out with the plastic tape. So you got to be careful because it will deteriorate too. You just want to get to where the wire, well, let me see if I can get one off kind of fast. See how it deteriorates? It's just old bulldog tape. That's what it used to be called. It's cloth tape. And there's the wire. So we'll undo some of that because we're going to put heat shrink on it. We don't need this old wire. Okay. And there's the wire, and you see it's soldered to that wire. That's the head wire. So we'll take that off. And yes, they soldered it, and that is good. So we're going to protect that there with heat shrink down to the coil. And we're going to unsolder that, clean it off, and put a new one on. And I'm going to do the same with this one. And we'll solder a new wire on there, a new wire, and then put the stator back into the case, which is just the reverse process of taking it out. See, I want all that off there before I go playing with it. I decided against the rubber gloves because I knew this was going to happen. I mean, they did what they could back then, you know. This is what they had to work with. They didn't have shrink wrap. They had this awful cloth tape. And you got to be careful. You don't want to strip the wire insulation off. You just want to strip the dog tape off if you can avoid it. If you strip the wire, hope that you don't get it down to the stator because it'd be hard to insulate it. There it is. So there's this soldered where it was soldered. But I'm going to try to take a little bit more of this off because I'd rather have heat shrink than this gummy stuff. It's deteriorating anyway, and we don't want it causing a problem down the road. Okay. I'll go ahead and get this connected, and then see, there's the wire, and I'm going to put heat shrink right over that one. That one came out in bad shape, so let me just cut it here and slide that right off. And I'm going to, this is insulated coil wire. It's the actual field coil, so I'm going to just slide shrink wrap all the way down. And it's fine. It's no, you can see there, it goes nowhere near the stator. It goes right into the coil insulation. And this one does too. Right there. Goes right into the coil. You got plenty of tolerance there. But this one, I think I might just leave some of that. Let me cut this off because we're going to solder a new wire on there. And we'll try to leave some of that on it. There we go. Doesn't matter, I can just use smaller heat shrink on that one. And since this one came out this way, I think I'm going to use that there, and I'm going to use that one over there because it's easier to get to. So I'm going to shut my camera off so I can clean my hands and get that cleaned up and soldered and shrink wrapped, and then I'll show you what it looks like. Okay, I got the head wire soldered in and shrink wrapped in multiple places with different side shrink wrap to make sure it stays fine. I cleaned the coil and the housing. This is black paint there. So So, but I cleaned inside and out of the house, stator housing, the actual iron core, and I cleaned the coils off. So I'm getting ready to put it back in the case, and I just wanted you to see how I had that. And that plastic insulator there is very strong, so that holds it. You see it won't move, it won't do nothing, and nothing's exposed, so we're in good shape. Going back into the housing and then back into the fan, and once it dries up really well, we'll give it a try. Okay, I got the fan back together again with the new head wire. Plenty of play in the wire for it to do its oscillation thing, no problem there. I got it suicide wired because I got to pick up another plug for it to my Variac. And before, I was able to stop this on low gear. Right now I'm on I think I'm on 110 volts, which is what it's rated for. Yep, 110.6. And of course we're drawing no current, no wattage, because it's off. But if I turn it on high, you see it's drawing 60 watts, dropping down to 57 as it picks up speed. And that noise will go away when the blade's on it. That's just the armature's all the way forward. See if I tilt it back a little bit, which the blade will pull it back. But that's high. On medium, we're down to 42 and a half, 43 watts. 43 watts, and it's got some power there. And on low, we're drawing about 37 and a half watts. And I can't just stop it like I did before. I mean, I can grab it really hard, but before I just touched it and it would stop. So the head wire is working fine. I'm about to put a blade on it and just see what it does with the blade on it. And then I got to get a plug, and we'll be able to plug it back up into the mains. So all the speeds are working, and that's where I'm at. Okay, I got the fan assembled back together. I'm setting at 116 volts, which is rated at 110. So I'm a little bit above. It'll run fine on regular mains. But I didn't want to push it up too high to do this demo. Actually, let me bring it down, and we can always bring it back up. So we'll put it at 110, what it's rated for. There we go, 110. Okay, on high, you'll probably hear some wind, but it is spinning. So it's doing a lot better than it was, and it's drawing 62 watts. So that's not bad, under an amp, 0.8 amps. Okay, we go to medium. That's medium. Still turning pretty good. On our medium, it draws 50 watts, or 49, which is 0.69 amps. And then on low, before it would hardly even turn. You could just barely touch the armature and it would stop. It's not the most quietest fan, but it's not a Vortelex, GE Vortelex, and it's an older model, so, but it is pretty quiet. Okay, probably noisy in the speaker of the mic of the camera here, but all right. So now if we put it on low, it draws 40 watts. So it's 62 amps. If we put it on oscillate, there it goes. it's oscillating. On slow, it drags it down. So, but it's doing okay. It has a little trouble. It's got some age, but it's doing much better. And definitely clean sounding. And it's drawing 41 watts on low with oscillating. That brings the wattage up. It's still only 0.6 amps. So if we go to medium, it moves a good amount of air. It's doing pretty good. And there it draws 50 watts, or 0.71 amps. And if we go to high, it does fine on oscillation on medium and high. On low, it's a little sluggish, a little jumpy. The jumpiness is just that it's old and, you know, it's obviously been used, but it's got many, many years of life left in it. And it's a nice fan. And now it's got a new head wire, which you can see there. A new line cord, which is that plug there. wouldn't plug into my amp meter, so I had to plug it into a cheapy extension cord. And okay, so what does it do at mains voltage? Well, on high, oscillating would be the worst case scenario. So we'll bring it up. Now my mains is 120. I can already hear it running much better. So that's my mains there, but we'll bring it up to about 124. Okay, so that's way above what it's rated. And it's running fine, running good. Wattage, it's a little, not bad, 70, 76 and a half, you know, but it's still under an amp. So that's pretty good. So there you have it. Nice GE fan with GE blades. And it does good. Yep, and it's all ready. I cleaned it up a little. I didn't, you know, shine it or restore the paint or anything. I touched up the paint. There was some scuff marks. It probably should be painted at some point, but it's fine. There's no exposed metal so that I could see. If I missed any and the owner finds some, he can touch it up or decide if he wants to paint the fan as a whole. The blades, we just cleaned them with some mild detergent and the GE label. I didn't use Brass X or anything like that on them, and that would definitely help them. I wanted to leave it as original as I could because I didn't know what the owner was going for, whether they wanted shiny brass or, you know. But we got the dirt and grime off the blades because that makes it more efficient. There's, you know, some spotting, some tarnish. It's got a good patina, but it could be cleaned. And if you want it shiny, you can use some Brass X or something like that. Anyway, Brasso. That's it. And that concludes this video. Thanks for watching, and I appreciate it if you would like the video and subscribe. It definitely helps me keep these videos going. YouTube gives us exposure based on the number of subscriptions we get and the number of likes we get, so you know, we appreciate it. And if you share it on Facebook, that helps us too. So anyway, there you go. Thank you.